A bicycle is one of the most efficient modes of transportation today. Adding an electric motor and a battery make it a viable means of commuting longer distances. Most electric assist bikes use a hub motor integrated into the rear wheel, but this poses a problem. Hub motors have a fixed gear ratio to the rear wheel. This means that, at near zero speed, the electric motor is barely spinning. Power produced by the electric motor is torque multiplied by rotational speed. So if the electric motor is barely spinning, then the power output is near zero, and the efficiency is also near zero. Because of this, the power assist of the electric motor is extremely small until you get up to cruising speeds. We want to operate at the peak power, efficiency, and speed of the motor as much as possible in our concept. But how can we achieve this? The answer is in ourselves. Humans have a comfortable speed that they like to pedal at, between 50 and 60 RPM. That is why a typical bicycle may have 21 speeds, because we like to stay close to 50 RPM at the crank. This provides a consistent, self-regulated speed that we can connect to with an electric motor. But what speed does the electric motor want to spin? Most hub motors have a 5:1 fixed gear ratio to the rear wheel. A typical human rarely exceeds 20 miles per hour on a bike, which for a typical 26-inch tire gives us a motor speed of around 1250 RPM. The peak power and efficiency point of an electric motor is typically at least twice that speed. This means that, for a hub motor listed at 500 watts, the user will probably never get 500 watts out of it on the bike. We want a speed closer to 3000 RPM that connects directly to the crank. Now for the next big question, how much power do we want from the motor? The power of a cyclist on flat ground is mostly spent overcoming aerodynamic drag. For a cyclist in the drops position, where aero drag is the lowest, they will need to overcome about 200 watts of drag at 20 miles per hour. If our goal for the electric assist bike is to equal the power output of the human, then a 250 watt motor would be sufficient. Because we will spend most of our time near the peak power point of the motor, we don't need a heavy 500 watt rated motor to accomplish our goal. This mid-drive, as it's called, architecture is on the market by one manufacturer. However, there is one problem. The people who consider commuting by bike are those who enjoy cycling. With most e-bikes on the market, there is no quick way to remove the extra weight and function of the electric parts and allow the user to use it as a traditional bicycle. To get around this, we can take advantage of the fact that the highest gear on the crank is not typically used during a commute. We can transfer the power from the electric motor to this highest gear with a chain. Removing that chain or belt would completely disconnect the electronic components from the drivetrain, allowing them to be removed. It would also allow us to install the electric components as a kit on existing bicycles. Our mid-drive e-bike concept consists of a pancake electric motor with integral 5:1 planetary gear set in the center of the bike. The output of this motor module is connected to the existing high gear of the bicycle crank. A 5 amp-hour lithium-ion battery pack consisting of 4 Ford Fusion hybrid battery cells is housed above the motor in the center of the frame. Mounting hardware is not shown. The full assembly includes the motor housing, the stator, the rotor, the sun gear, the planetary gears, the planetary carrier, the ring gear with output, and the chain, and then the 5 amp-hour lithium-ion battery. The battery consists of the bus bar, the cell spacers, the 5 amp-hour Fusion hybrid lithium-ion battery cells, additional bus bars, the terminal retention nuts, the motor controller, and the battery protection circuitry, as well as the casing. With 4 Fusion hybrid battery cells, we would have a 7-mile battery pack. 4 Focus electric cells would make a 22-mile pack, and 4 Fusion plug-in cells would make a 34-mile pack. This is based on a steady cruising speed of 20 miles per hour. All 3 packs would still fit within the center triangle area of the bicycle frame.